Hello everyone, welcome back to our course. Today we have day 2 of our course on designing instructional visual media, and we're looking to answer the question, how do learners process information? Specifically, we're going to look at some of these key theories related to our course, and today's theory is going to be on cognitive load. So we're going to look at cognitive load theory today. Now, before we can understand cognitive load theory, we must first understand the theory it's based on, which is the information processing theory. Okay, this got popular in the 50s. A lot of psychologists were working on this. I think the term was originally coined by George Miller. But it essentially looks at how the human brain stores information and compares it to that of a computer. Okay, where we have a working memory, we have a long-term memory, and we're trying to encode information into that. Here you can see a pretty good graphic that kind of breaks down the different stages, and we'll kind of go through them piece by piece. Okay, so when someone is trying to learn something, and they're trying to encode it into their long-term memory, first things first, they have to take that incoming information. Okay, so information's coming in, maybe it's text information, maybe it's verbal information, audio information. Okay, but that information is then stored in kind of a temporary memory called our sensory memory. So the idea here is that we're constantly taking in things with all of our senses, and we're deciding kind of in that split second, we have all these different brain functions working on, is this important, or is this something that we don't need to know, something that we can just forget? Okay, so that's kind of the first stage. So our senses pick it up. We see things, we hear things, we smell things, and then the brain thinks, is this important, or is this just background noise that I can forget right away? Okay, if it is something that is important, it'll pop up into our working memory. Okay, so now it's kind of on our mind. It's something we're thinking about in the moment. Okay, and from there, we have a series of places we can go. Obviously, if something's in your working mind, it's not super important, or you haven't done a good job retaining that thought, a lot of things we just forget, right? You're thinking of something, and then the next moment it's gone. Hey, where did that thought go, right? That is our working memory just forgetting something. And this might happen because it's not important. It might happen because we were thinking about something else, right? There's lots of reasons that we might forget something out of our working memory. Okay, one kind of natural strategy I think a lot of people develop, if I want to keep something in my working memory, we can utilize rehearsal. Okay, this is repeating a phone number over and over and over until you can memorize it. Or this is saying a piece of information back to yourself, maybe a definition, over and over and over to try to learn it for a test. We are rehearsing something, we are repeating it over and over to try to keep it in our working memory so that we can encode it into our long-term memory. Okay, so long-term memory is where we want to get to. This is where learning takes place. This is where something is essentially written down into our brain so that we can access it later. Okay, and the way we get to that long-term memory is something is in our working memory, we find it's important, and we encode that into that long-term memory. Okay, so there's kind of a two-way street here where if we're writing something down into our long-term memory, we call that encoding. Okay, when we're thinking about that thought later, okay, and we pull on that information from our long-term memory, we call that retrieval. And this kind of cycle, this information processing theory, is what a lot of research is based on, kind of moving into the more recent learning theories and that sort of thing. So information processing theory, once again, came out in the 50s. Very popular idea. It's a way to look at things and kind of understand how that mind works. And it really does a good job leading into cognitive load theory, which is our main point of focus today. But before we get to cognitive load, there's one more idea I want to talk about, and that is the idea of schema. Okay, so schema is the idea that everyone has their own sort of mental framework, right? They have their own long-term memory, and this memory kind of builds connections between these different ideas and different experiences of your life. So the idea that everyone has kind of their own mental framework that we're fitting these ideas into is the concept of schema. And this is another important one for cognitive load because everyone has a different long-term memory. Everyone has a different memory that they're fitting ideas into, a different schema, right? Where you can see in this relationship here, or this picture, they're connecting leadership to business and friendship, which is connected to chess, right? Which is connected to golf and baseball. So when they're learning something new about leadership, this person is tying it back to golf. They're tying it back to baseball and chess. And they're kind of figuring out how these connect. So since everyone has these unique schemas, everyone's kind of learning process is different because we're building different connections to learn maybe the same idea. So kind of no two schema are alike, and no one is going to learn something the exact same way as someone else, which is kind of an important concept as we get into cognitive load. All right, cognitive load theory. This is a very popular one today. This came out in the late 1980s, so a pretty recent educational theory in terms of that instructional theory kind of timeline. But this was by John Sweller, okay, popularized by John Sweller and has been used a lot since. But once again, the late 80s, Sweller kind of broke down the ability to think into three parts. Okay, and he did this by looking at problem solving in mathematics. Okay, we're gonna take a look at the article he introduced us in a little later today. But he essentially said whenever someone's trying to learn something, there are kind of three different loads going on in their brain, right? And cognitive load is how much thinking is being done, how much processing to learn something. Okay, there is intrinsic load. Intrinsic load is kind of the internal difficulty of learning something. Okay, so the intrinsic load is tied to how complex the new information is. Okay, so when you're learning about calculus, that might have a very high intrinsic load. Or if you're learning organic chemistry, right? The topic itself is very difficult. It's not about the presentation that's hard to learn. It's not about anything other than that. That is just a dense topic and it's hard to learn. Well, we would say that has a high intrinsic load. Okay, there's also extraneous cognitive load. Extraneous, okay, you might have seen that word before. It's got extra right in there, right? This is kind of extra cognitive load that isn't quite related to the learning process. Or maybe it's tied to the learning process, but it's not a direct requirement to learn something. Right? A lot of times extraneous load is there, it's going to distract you from the working memory. Instead of learning new information, we're distracted by maybe there's a poster on the wall, right? Maybe there is a flashy picture in a presentation that's distracting you from what's really happening. Or, a big one for me that's frustrated me as a student and that I see a lot. Maybe there's a wall of text that you're trying to read and the professor's talking to you at the same time, right? And you're getting kind of these conflicting signals that are distracting you. Well, that is extraneous load. Okay, something that we want to minimize, something that we don't want in our lessons. An extraneous, a lesson with a lot of extraneous cognitive load is very difficult for the learner because they're being pulled in different ways and they can't focus on the real topic at hand. Where we get into a more technological world, I think extraneous cognitive load is a really important subject because if your application is designed in a way that's confusing, like how can a student learn if they can't work the learning app, right? And that's where that extraneous load comes in. All of our brain is dedicated to understanding how this app works. How are we going to learn content? And then finally, our third type of cognitive load is germane load, right? The germane cognitive load. And this is tied to the processing of information and integrating it with previous learning. Okay, so germane cognitive load is how we connect from a new idea to a previous idea. Okay, so germane load is kind of how how our working memory is encoding things into our long-term memory, right? We're building those connections. We're tying this new topic to our schema. So that is germane cognitive load, and those are kind of the three different types. And we're going to talk about them, and we're going to see how those come up in visual media as we move forward in this course. Okay, now I just want to kind of look at these topics one more time, piece by piece, and really break them down. So we've talked about intrinsic load. Right? Intrinsic cognitive load is load directly related to the learning material. Okay, so it is the learning material itself. It is thinking about, how do I learn this content? How do I understand how this works? Effective design now is going to give learners the appropriate amount of information at a time. Okay, so if we're giving someone too much information at once, we might overwhelm them with the intrinsic cognitive load of the lesson. And on the flip side, if we don't give them enough, they might become bored. So it's a lot of education is finding that balance, right? The Little Red Riding Hood idea. Not too much, not too little. Right? We want to get just right, just the right amount of information at a time. And once again, that depends on each learner, so it's very difficult. But there are a lot of strategies that kind of help build around that idea of giving learners that appropriate amount of information. Things like chunking, where we're splitting our content into bite-sized chunks so that students, don't have to understand the entire concept at once. Maybe we give them it in pieces. Scaffolding, okay, where we're kind of building up to an idea. We're talking about the prerequisites that go into it, and we're making sure students have all the foundations they need to understand this new idea. And there's also things like micro-learning, okay, where we're going to try to not give you a lot at once. We're going to give you bite-sized pieces, maybe 5 to 10-minute videos, to not overwhelm the learner with too much information. Okay, so that's kind of what we're looking for with intrinsic load. We want to give students just the right amount of information, and we want to find strategies that help us do that. As far as extraneous load, okay, we've talked about extraneous load. It's the extra that's going on in our lesson. It's the load of distractions, right? What's taking away from our learning? What is the learner thinking about instead of thinking about the topic at hand or the new subject? Well, effective design is going to minimize these distractions. We're going to have intuitive learning systems that make sense right away, and try for distraction-free environments. Okay, so that intuitive learning systems is a big one for me personally. If a student is looking at a note taker, or they're looking at classwork or homework or a learning app or a test, anything like that, and their thought is, how do I navigate this learning system instead of what is the content and what am I being asked to do? Like, that is when you're going to lose students. We really want to clean that up. We really want students to be able to just dive in and start working. We don't want them to spend a ton of time thinking about, how am I supposed to fill out this note sheet? What am I supposed to write down? Where does this go? Where do I click to get to the lesson? Am I on the lesson or the quiz, right? All these ideas are just distractions that are built into the learning environment that we want to clean up. Okay, we want to make systems simple. We want to make them efficient, intuitive as possible, right? If students can just come in and complete the lesson and not think about the medium that you're sending that lesson to them at all, that's what we want. Okay, as little extraneous cognitive load as possible. Now, what are some strategies that kind of help us accomplish that? Well, user experience design is a big one in today's day and age. This is designing with the user's experience in mind, where we're trying to minimize extra clicks. We're trying to keep things simple. We're trying to make sure that our learning applications function as the user would expect them to. Okay, this is things like making sure when we're underlining something, it's a link and not just an underlined word that's going to confuse the user. Making sure there's a home page button clearly visible at all times to make that simple for the user, things like that. So considering that user experience when designing our learning and our applications, very important, really helps us kind of tear down some of those distractions. Extraneous load also comes up a lot from an accessibility standpoint. If students don't have the tools necessary to take part in the lesson, that's going to be a big distraction for them. If you're asking students to read long text and they're dyslexic, or if you're asking students to listen to something but they happen to be deaf, obviously that is going to create a barrier to learning, right? A distraction that's kind of pulling away from the content. And an approach to handling that is UDL, which is called the Universal Design for Learning. Okay, a lot of these topics will probably come up in your other classes. But the idea behind a universally designed learning is that we're going to design our learning in such a way so that it's accessible to all people, and kind of figuring out how that works. And really what that is at its core is it's minimizing distractions due to a lack of accessibility. Okay, if we provide subtitles for everyone, then that hard of hearing student doesn't have that distraction of what did they say? I'm not quite sure. Right? So that sort of thing. And the last strategy I wanted to talk about was routines. Routines really help clear up that extraneous cognitive load, because when you have routines, students know what to expect. They know how things work. Okay, the day becomes very intuitive to them. They understand how the system works, and so they're not thinking about that learning system because they've done it before, because it's a routine at this point. It's built in. So that's another kind of way to address that extraneous cognitive load. Okay, and last up we have germane cognitive load, which is the cognitive load tied to building connections to previous ideas. Okay, this is the information processing step where we're encoding our information. We have it in our working memory. We want to tie it to a previous idea to cement it into that long-term memory. Okay, that is germane load. Effective design is going to connect learning to prior learning or to real-world scenarios, right? We know that you have memories in your brain. You have your schema. We want to connect to that schema. We want to tie this new topic to something you've already learned or something you might know about in the real world. Okay, a great idea for this in education, or for me specifically, I taught high school math. I would love to bring up sports students played when teaching different concepts, right? When you're teaching Pythagorean theorem, that applies to baseball, that applies to football, that applies to soccer. And by tying it to those scenarios, you're helping that student really cement that idea. Because now when they think of Pythagorean theorem, they're also going to think of football. They're going to think of that pursuit angle and how they catch that guy running down the sideline. And hopefully that connection sticks and they're able to learn that idea. So some strategies for really cementing that germane cognitive load. We have rehearsal, or kind of repetition. The more we repeat something, the more we talk about something, the more it is coming up into that student's working memory, and the more likely we are to encode that. Okay, so bringing things up multiple times, referring back to the objective, all of that is going to be a great way to help kind of cement that cognitive load, or that germane cognitive load. If we want to build that connection, right, the more times we bring it up, the more times it is in that working memory, the more chances we have to encode that into our long-term memory. Another option, note takers. Note takers can be a great way to set up these connections that we're trying to build. Right? You can draw that connection for them and the note taker, and then they're just filling in the blank, and it'll have that connection pre-built and really emphasize that for your students. So good note takers can really show those connections and how they work. And finally, Gagne's events of instruction. Okay, this is another instructional design model that we'll go over in this class. It's similar to ADDIE, but more specific about kind of what stages you want to design. But in the events of instructions, Gagne talks about remembering prior learning, okay, and priming students to connect to that prior learning. So in Gagne's mind, we want to call back to our prior learning so that we can connect the new information to it. And this is done specifically to manage that germane cognitive load. Okay, and that's all we have for today. I don't want to introduce too many topics each day because I know this is a summer class. We're moving quick. Right? I'm trying to keep that intrinsic cognitive load down. So we're gonna do these little micro lessons where we talk about topics, and then just like yesterday, I'm gonna give you guys a couple tasks so that you can kind of extend that learning and learn a little more on your own. So I have a reading for you, an article. I'd just like you to skim it. Okay, it is a little long, so I don't expect you to read it word for word. But it is called The Cognitive Load During Problem Solving, The Effects on Learning. And this is John Sweller's 1988 paper where he introduces cognitive load. Okay, so this is kind of the origin paper for cognitive load. It is a research paper. It does dive into problem solving in mathematics. So if it gets a little too much for you, that's okay. Just kind of look around and see how he introduces the topic and how he sets up his research project. Because I think it's pretty interesting to look back and see something that started off as kind of a basic research paper, and it has turned into this dominant theory in learning education today. So pretty fascinating there. I also have some options for you to extend your learning. Okay. These are things that aren't quite required, but if you're still struggling with some topics, maybe it's good to check out. There's going to be a video on working and long-term memory, a video going over intrinsic, extraneous, and germane cognitive load. And then finally, I was able to find an ACE conference speech by Sweller himself. So that's really cool. As we get into these more recent theories, what's fascinating is these guys are still alive, or they were at least alive during the video recording era, so we can see them firsthand talk about some of these ideas and see their presentation style. Something I found really interesting when checking out this conference is Sweller's presentation style is very much obvious. It's very obvious that he practices what he preaches, and he's very minimal with his on-screen graphics. It's pretty much a title, and he just talks about a topic. So you can see he's a very minimalist guy, which makes sense because he's trying to minimize that cognitive load and make things as simple as possible for his learners. So check that out if you'd like to hear from him, or maybe just check it out and take a look at his slides, because that's interesting to me that he is really minimizing that cognitive load to the point where his presentations are bare bones, and it's an interesting design choice that I kind of geeked out over a little bit, I guess. There is a practice quiz. Okay, so try that 1.2 practice quiz. I did realize today when I was making the practice quiz that there's an option to shuffle answers. I did not have that on yesterday, so apologies if you took the one practice quiz and every answer was right at the top. That was my bad there. Hopefully that's fixed. If the answers still aren't shuffling, if you could just send me a message on Web Campus, I'd really appreciate it, because I'm not quite sure what the students see or how that mixes up, that sort of thing. I'm kind of new to using those quizzes, but try that out if you'd like to kind of test your knowledge on, it's mostly on intrinsic, extraneous, and germane cognitive load there. And finally, our assignment for today is we're going to have another discussion, so you're going to answer the discussion too. Okay, so we'll pop over to the actual course now and take a look at this. All right, so here we can see today's module. We have the cognitive load PowerPoint, if you'd like a copy of that. The article from Sweller that I'd like you to skim. Okay, and then a couple videos on the working and long-term memory, intrinsic, extraneous, and germane cognitive load, and that ACE conference from Sweller himself, if you're interested. Those extend your learning opportunities. We have the 1.2 quiz. Okay, you can test your learning there. Remember, the quizzes are just for practice in this class, so feel free to try it out and get some feedback there. And here we have discussion 2. Okay, so discussion 2, once again, we have 4 questions. Question 1, I would like to know if you've encountered cognitive load theory before, and if you have any questions on the theory or how it works. And then question 2, 3, and 4 are about the different types of cognitive load. And I would like to know, why do you guys think it's important? This is a course about designing visual media. So why is it important to consider intrinsic or extraneous load when designing those visual medias? Okay, so if you guys could make your posts by this Friday, so that gives your chance, or your classmates, a chance to respond by next Monday. And that's all I have for you today. So hopefully you guys have a great day, and I will see you tomorrow.